This is how I go about honing. I just swung the drill press table out of the way. I've got some oil in there. I can feel the hone coming out the bottom with my left hand. I like to keep it moving. And I'll do that for about 5 minutes and then examine it. There we have it. Bore looks real good. Now this is the single most important thing on a Stirling engine, is to have a very good bore and a very good fit with the piston. Now if you can't pull the piston out of there and have it pop like that, it's not going to run. So that's our test, the bounce test with the piston and the pop a top or two. Jim Ed Brown. I'm at the metal cutting bandsaw and I'm going to cut it along that line, leave just a little bit to sand it down to the line. And you know, I'm not going to take anything off this end at this time, and that can be done later if necessary, and it may not be necessary. It is a tremendous luxury to have all the different tools that I have in the shop, and I thank the Lord for that. On any Stirling engine there is a connection or a port or a hole that connects the hot side with the cold side. So there's a hole in here, and the hole is drilled from this point, and I'm going to drill 13/64 all the way through here and into this one, including through the steel. Then when I'm done, I will tap this 1/4-20 and put a plug in there. It'll just be a set screw with some Loctite on it to seal it. And then there's a connection between the two. I'm not going into the theory of why we're doing that. You got to look into the other video for that. But there has to be a connection between the two. So that's what I'm going to do now. I'm back at the Rockwell drill press, and I've already drilled a 16th inch pilot hole. I like to start with a 16th inch hole where I've center punched it, and then the larger drill is going to follow that, and it will not deflect, but that goes in just through that wall so far. But I'm going to drill all the way through this wall and this wall, down through this and into the tubing. And that's a deep hole, so I'm going to use plenty of this. I'm going to clear the chips. I may not show it all, but I believe myself to be perfectly vertical, so I don't end up drilling out the side. This is a 5/16 drill bit, and I have about equal space there with that. And I'm in my palm green drill press vise on the side, laying on its side, which I think is a good way to hold that. Continue that all the way through. Then I'll run the hone through there again in order to clean up where the cross hole went. Now I'm going to tap the hole 1/4-20, and then I'll plug it with this 1/4-20 set screw with a little Loctite on it. Let it set overnight. Then I'm going to run the hone again through the bore here to clean up where the holes came through. This is a 1/4-20 taper tap. It's very easy to tap straight with the tapered tap. It has 7 tapered teeth. And there we go. I need to plug this in, so I'm going to make a little plug out of this 3/4 aluminum, and I have to turn it down to 0.738. It'll only be about a 1/2 inch long. I've already faced the end of it, and I want it to be a slip fit because I'm going to use Loctite to hold it in. Not very critical at all. Alright, the plug has been turned to diameter, and I'm going to cut it off. And there's the plug. It's almost too loose, Lautrec. But remember, when you use Loctite, you need just a little bit of space for the product. So later on, I'm not ready to do it yet, but I will put some Loctite on and put it in about that deep. And I put a little circle on there strictly for ornamentation. I do believe I'll make the cranks next. So we've got a large crank on the hot side and a little bit smaller one on the other side. And there are the castings. They both will have a 3/16 reamed hole in the center, and I cast those punch marks right in there for some reason, like I was going to make thousands of them or something. And then this hole and this hole will be tapped 540. Now a 540 thread is an 1/8 inch OD, but I have to look up what the tap drill size is. And I'll take these on the band sander and knock the gates off. Just take a minute. I keep a 1/16 inch drill bit in my little Cameron precision drill press, which is right here on the bench, and I like to use that for the initial pilot hole. Or I won't drill all the way through, but these are already center punched, and if I just drill about halfway through, I've established the hole. Then I go over to the big drill press and drill the final sizes. This is very handy because it's always here on the bench ready to go. Now I'm going to drill and ream these holes off camera and just on the regular drill press and freehand. Now small parts like this I usually don't hold in a drill press vise because I like to let them drift around, and with aluminum there's little chance of it spinning around and hurting you or cutting you. Alrighty, I've reamed a 3/16 hole in the center for the shaft and tapped a 540 thread here. Now this crank will be Loctited onto the shaft, that is if there is such a word as Loctited, and it'll be put on there permanently. However, we need to take the thing apart, so on the other one I'm tapping a 540 hole from the side, and that will lock this crank onto the shaft. Remember, there's very little torque here, so that's not going to slip. This also will allow me to time the engine because one side has to be 90 degrees out of phase with the other. So the center hole is reamed 3/16. That hole is 540, and then this hole that I am now tapping is 540. Well, it's day 3. A new day, and here's what I've done so far this morning. Now I'm not working 8-hour days, I just work 2, 3, 4 hours, whatever I'm in the mood for. So I've put Loctite onto the shaft, and which fastens it onto this crank. And I have temporarily put the other crank on with a socket head cap screw. I couldn't find any set screws. I think I got to go to the hardware store. I tapped that 540 and I got to stop doing that. I got to start using 440. 440 is very common. 540 screws and set screws and so on are difficult to find. You can order them, but you're never going to find them at your local hardware store. Now I like to space these out. So in here I got a washer, and in here I got 2 or 3 washers, whatever I need to move things back and forth and to keep the parts from scraping. And then I've got my alignment here where pretty much, if you look here, when I lay a straight edge on there, I'm coming fairly close to the center. So that's what I want as far as this spacing is concerned. Now when you do model making, you ought to make yourself up a little setup like this. I've had this for 20 years already, and these are all the common sizes that I use. For instance, here's well, there's a number 3 down at the end. I seldom use that, but here's the 440, 540, which is in my tap wrench, 632, 1032, and so on down the line, or 832, 1024, 1032. But in the front here, these are the tap drill sizes and marked appropriately, like that's a 29 for the 832. And then on the back here is the clearance size. So I have tap drill, tap, and clearance for all the common small sizes that I use, and I go clear up to 3/8 here, and I keep a center drill and my little tap wrenches and everything there. So make yourself up one of those. It is so handy, and you don't have to run around looking for things. And you can even take this over to the drill press with you. Now those little washers I just talked about are 3/16 fiber washers. I've got them in the 1/4 inch too, and I buy a whole bag of them. They're like super cheap, but again, you won't find them at the local hardware store. Order them from McMaster Carr, who has all of these supplies, and they get them to you in a day or two. More obscure things that you're not going to find at your local Ace Hardware. I wasn't going to take this engine apart because I have used silicone seal here to seal this surface. But I wanted to show you how it works, and also I wanted to get the dimensions off of this. And this is my displacer. And the displacer moves back and forth in this hot end chamber. Remember, this is not a piston. It is a displacer. It displaces hot air. Moves the hot air from this end onto this by moving back and forth. Now you want this to be as light as possible, simply so that the thing doesn't start vibrating. And even at that, we got quite a bit of weight here moving back and forth. But what I like to use is a marker, a magic marker. And you know, I'm not sure you can buy these aluminum ones anymore. Everything's plastic now, but I had this in stock, and it's a brand new one. But what I do is I will sand this end off on the sander so it's smooth like this, being careful that I do not sand into it and ruin it, because I'm not sure I can get another one of these. And then I'm going to cut it off here, probably with that little abrasive tool. And now I got a dimension here that I can go by. I believe there's like a felt wick inside of here that has all of that nasty ink, and I'll throw that away and clean it up real good. And then I will make a plug right here that is a press fit into this, and that goes in about up to the P, and this rod again is Loctited into it, and we need a very good fit here, and that's why I reamed that before. We do not want air to escape out of there, but yet you cannot use any kind of seal or gasket or packing or O-ring. It has to be very free. It has to move freely. So that's what I'm going to make now. I'm going to take this and cut it like I just told you, and start making this little plug here, which is simple enough to make. Yes, I cut this with the little abrasive tool, and this is what's inside there. It's kind of like a big old black ink piece, and this is for inquiring minds. I want to know what's in there. See, this doesn't weigh much. Now I'm going to take it onto my Delta belt sander, sand this off square, and sand it down to what I just showed you there, and then I think I'll clean this with a brake cleaner or something, and then this is ready to go. And I think those cost about $1, but you don't want to make these out of solid aluminum. Even though aluminum is a lightweight metal, it would be way too heavy. So it needs to be something that is tubular, and if for some reason or another Well, when I designed this some time ago, I happened to get, along with this broom handle and this, a very good fit. Now, there needs to be a space around this. It is not a piston. It needs to move back and forth without touching the walls of the tubing, but yet be very close to touching them. And go to that other video that I talked about if you want to know why I'm doing all of this as far as the theory is concerned, because I'm not getting into the theory. I'm just showing the construction of a Stirling engine. There it is to this point, squared off nicely on the belt sander. This end sanded down. I was careful not to go all the way through it, because remember, this has to be airproof. We don't want any air getting in here. Sometimes when I make a part, I do make a little sketch. I said I don't work from drawings, but that's going to be the plug made of aluminum, and those are the dimensions I will follow. And I've already got the aluminum set up in the Atlas lathe, and I got it reamed 3/16 already and ready to turn that little step on it. Well, there it is. I'm not going to show all of this. It's on the Atlas lathe now. And I've already reamed it 3/16 and I got a step on there. And I realized that this is a 750 3/4 inch aluminum, so I didn't turn that other diameter, which I showed as 740, because it's going to be close enough. And I put a mark on there, a pencil mark, and I will take it over. Remember, I'm going to Loctite this on. Now I'll take it over to the closing lathe and cut it off on that line, because the closing lathe is still set up from yesterday, so that's something I can do in just a matter of 5 or 10 seconds. And you know, it's so handy to have more than one lathe and leave some set up, you know, with a common operation that I'm going to do quite often in the model making, and that's cutting off. That's the finished plug, and this took really less than 5 minutes probably to make, and I'm going to put some Loctite on there. And don't ask me what flavor of Loctite this is, because this is what I've had for a long time and you can't read it anymore. See what I mean? And I'm going to put that in there with the Loctite. Pretty good fit. And then this is 3/16 rod, and did you notice that the other one had 1/8 inch rod, and I just changed to 3/16. It might be a bad idea because it causes a little bit more weight. But now I'm going to Loctite this in up to this line. I already made that line on there. And then this will set for a while, and I may not get back to this for a day or two anyway. Remember, Loctite sets up in the absence of oxygen. It is an anaerobic. There we go. This will have to be trimmed again later when the length is determined. Now, for your information, when the displacer moves back and forth in this tube, it's necessary that it move all the way to the front, leaving almost no space, but yet not banging the end cap. But we want our stroke and our length and everything here such that it comes almost to the end, and then on the reverse stroke comes about that far to the back side. And you'll have better operation that way. Now, we just use air in here as a gas, but some Stirling engines used other kinds of gases. I don't know if it was helium or what, and they will run better, but we have no way of doing that. Plus, we wouldn't have a good enough fit to really contain that rare gas, so we just allow atmospheric gases to be in there. During the last half hour, have been busying myself with some other little parts that I'm not going to really show you how to make. But this little part here on the end of the displacer rod is a transition piece. I don't know what to call it. And it's going to have the brass connecting rod from the crankshaft. Now, I already had several pieces made up from some ill-fated project a while ago. They already had a slot and a 1/16 inch hole in them. So I just cut one of these off. I cut the end off, put it in the lathe, Hope this comes into focus. And I drilled and reamed this end, and the length of this rod is still to be determined, and once it is, I'll cut it off to the correct length and use Loctite to hold that on. I hope you guys don't object to me using Loctite so much rather than other mechanical fasteners, but it sure does speed things up. The connecting rod is a piece of flat brass that I already had. It's about a 1/4 inch wide and a 1/16 inch thick and indeterminate length yet. I do a lot of fitting and making pieces to custom fit whatever I'm doing rather than work from dimensions. And then the little pins to hold right here. All I do is use brads like Brad Pitt 16 gauge. Well, 16 gauge happens to be 1/16 of an inch, so I just cut them off to length and press them in there, and they seem to stay. And that's all you need. I could go to a lot more work and use something else, but these already have a nice little head on them. Well, I'm progressing nicely, but as I work through this, assembling or erecting, whatever you want to call it, I sometimes run into interference. And what I had happen here is that on this engine, there's really very little extra room here, or when you back it up all the way here, notice that this connector here is almost touching the crank. And I experienced that here as well, and it was even a little worse. So what I did is I moved this whole thing up. I drilled 2 more holes, and I moved the whole casting up about a 1/4 of an inch. And that took care of the problems that I'm encountering. And later on I'll just fill those holes with body putty before I paint it, and you won't even see them. But I've put the pin in there. This is not Loctited on yet, but I'm determining the stroke and where I need to drill this hole. And then I'll dry run it, and just by turning it over, and I still haven't cut the end of the tube off. I have to determine how far forward the displacer moves, and then decide where I'm going to cut that off and get ready to silver solder an end cap, and I have to make the end cap yet. So right now I'm going to off camera determine where I need to drill the hole in the brass connecting rod. I'll do that, and then I will have movement of the displacer as I rotate the flywheel. I thought I'd show you this step too. I've had a little frustration here the last few minutes, but I have installed a transfer screw right here. And if you recall what transfer screws are, those are really tiny ones, 540 size. They come in this little tube. But I was frustrated because the little wrench on the end here to install them, to screw them in, is stripped out, or never was made right in the first place. Anyway, there's a transfer punch in there, so that once I locate this where I want it, whoops, that came out, then I will tap the brass piece right onto the transfer punch, and that'll locate the hole for me. Now, as far as this rod here is concerned, I put a little mark on there indicating when the displacer is all the way back, a little file mark. So now I'm going to move it up just a little bit till that mark disappears, and I'm going to put this piece on, but I really need to probably use the Loctite on there so I can count on that. Position that correctly. Bring the crank around till it's at its farthermost position. Tap that. That will locate the hole for me. Then I'll drill that 1/8 inch hole and then cut the excess brass off. That's how I do my erecting, rather than by dimensions. But sometimes you run into little frustrations and interference like what I just showed you there before. Well, I located the hole on the brass connecting rod and I drilled it 1/8 inch, and this is a 540 screw, and you can see now that I have full travel. This comes fairly close here, just the way I planned it, and then on the back stroke we have plenty of clearance that this part doesn't strike the crank. And then from the open end here you can see how far forward the displacer moves. Now I can determine where I need to cut that off, and I'll cut it off so it's just a little bit, oh, let's say 1/8 of an inch longer than where the displacer ends. And then I need to make an end cap for that. One other point now. Since this is just a common round head screw, I will, off camera or later after the video is over, I like to make a little bushing, so I'll drill the hole 5/32 here and insert just a very short piece of this brass tubing in there to act as a bearing. Otherwise the thread tends to want to wear the hole out on thin stock like that. I have tens of thousands of screws in stock here in my basement shop, but invariably you don't have the one you need, and quite often the problem is they're not the right length. So in order to cut them off, I use either my little Dremel abrasive or this. Now do not attempt to shear the hardened screws off in a tool like this, because you will damage the tool. So these need to be ground off. Also, there's very little burr left when you grind them. The soft screws can be sheared with this type of shear. However, I don't have a 540 on here. This leaves a fairly clean end that as you back it out of here after you've sheared it off, it tends to get cleaned up, so you don't have a buggered up thread. But sometimes I take it on the little belt sander and square off the end anyway. But that's how I cut off and handle these small screws to cut them to the whatever length I need. Now I'm making the end cap for the displacer tube, and what I did is I took 1 inch stock, turned it down to 950, just a little bit back, and I bored a hole in it. And the tubing fits right into that, and it's only about 3/16 deep. And next I'm just going to part it off with a parting tool the length I need, and then I've got my cap made. There isn't any commercially made cap that I can go to the hardware store that would fit this, so that's why I have to machine one.